Hello guys, I am Asad Mujib and today we are going to solve a quadratic spline problem. As you can see, the problem is stated in front of you. The upward velocity for a rocket is given as a function of time using quadratic splines. We are given time and velocities. These are the times and these are the velocities at those particular times. We need to find the velocity, acceleration and distance covered. But actually in this tutorial we are not going to solve for these ABC parts. I'm just going to show you how to set up all these equations. So let's get started. Basically these are our times and these are velocity at those particular times. As you can see there are 6 points, but the spline is basically going through the spline. There are 5 equations of splines. The one spline is from, this is the one spline, first spline, this is the second spline, from this point to this point, this is the third spline, this one is the fourth spline, this one is fifth spline. These 5 splines going through these 6 points. Now we have to set up the equation, because these are the basic, this a1 t square b1 tc1 is the basic equation in quadratic spline. But as you can see that we are given these 5 points, so we have to set up 5 equations, these 5 equations, and each equation must be going through, each spline goes through 2 consecutive data points. Like this equation a1 t square b1 tc1 is going through these 2 data points. So we are just gonna plug in the values of 0 and 10 in this equation. But actually, as you can see, we are given the 6 point, and we have 5 splines. So this tells that we are going to have 15 equations. We are going to have 15 unknowns. So we have to set up those 15 equations. Now the first 10 equations we can get these equations from here. We're just gonna substitute these two values in these equations, and we're gonna get 10 equations from here. 2 from here, 2 from here, 2 from here, and rest from there. Just plug in those two values, and these are the answers. And similarly for A2, we're just gonna put 10 and then 15. And for A3, we're gonna put 15 first. Sorry, for A1, we have to put 0 and 10. For A2, we have to put 10 and 15. For A3, we have to put 15 and 20. For A4, we have to put 20 and 22.5. For A5, we have to put 22.5 and 30. So these 8s and these two equations give us our 10 equation. But still you have 5 less. You have 5 short. We have to set up 15 equations because there are 15 unknowns. So we are gonna set up the next four equations by not assuming, basically we are taking the derivative of first spline equal to second spline, because derivatives are continuous at interior data points. Derivatives are going to be equal at these points, because these tens are the same points, these both tens are the same points, so derivative at this particular point is going to be the same. So we are going to equal both of them and derive it and put t is equal to 10, because so at only t is equal to 10 our spines are equal. This is the derivative of this equation, and this is the derivative of this equation. We are going to substitute t is equal to 10, and this equation becomes our that this equation becomes the 11th, and similarly we're gonna equal a2 and a3 at t is equal to 15 because they are equal at t is equal to 15, and t3 t4 are equal at t20, and at t4 t5 are equal at t22.5. So the previous 10 equations and these 4 equations makes it 14. We still need one more equation. For that one last equation, we are assuming that this first is spline. Sorry, we have to go really back. This first spline is a linear spline. We have to assume this to get our last equation. This first a1 is equal to 0. This is the last equation. These all combined make 15 equations. And I've just substituted these values into a 15 by 15 matrix. And so we have to set up this 15 by 15 matrix. It's quite easy. Looks really hard, but quite easy to put on these values. And that's how we're going to get our 15 equations for 15 unknowns. That's some of the question. Thank you.